Launched in 2018, the Parker Solar Probe is a satellite that will be the closest spacecraft ever to the Sun. On its journey, it will analyze the solar wind and particles emitted by the Sun to protect us from the ever-present danger of solar storms, which could single-handedly fry many electronic systems that we rely upon today. It will come closer to the Sun than ever before, getting as close as 6 million kilometers from the surface of the star. Using a series of flybys past Venus, it will assume a decaying elliptical orbit around the Sun, where it slowly approaches the star until it is close enough to analyze the high energetic particles. In this video, we will look at the capabilities and goals of the mission, and what the Parker Solar Probe has already discovered just 1 year into its mission. To get close enough to the Sun to make analysis on the energetic particles, Parker must be able to withstand severe radiation and temperatures of 1400 degrees Celsius. Luckily, the spacecraft has incorporated an 8-foot wide heat shield, which is made from a carbon composite to protect it from the intense heat. Inside is a 4.5-inch carbon foam that will prevent conduction from transferring heat to the instruments. The instruments that the Parker Solar Probe possesses is a solar wind electron sensor, solar wind ion sensor, and cooling system. The spacecraft will also be flying around the Sun at incredible speeds of 192 km per second. That's fast enough to orbit the Earth in just over 3 minutes. Over its 7-year mission, the satellite will orbit the Sun 24 times, making 7 flybys of Venus. So far, the Parker Solar Probe has orbited the Sun 3 times, making many discoveries. A recent paper was released in December of 2019, highlighting the different phenomena that Parker has observed. So what are these discoveries? The first is that there is no cosmic dust in the near vicinity of the star. It has long been known that cosmic dust exists throughout space, and though minute, it is there. However, around 6 million kilometers from the Sun, the vacuum of space is devoid of dust. This can only be caused by the Sun's heat and radiation vaporizing any dust that exists, and creating a dust-free zone around the star. Another discovery that the Parker Solar Probe made was that the solar wind is not a continuous stream of particles like we experience from Earth. The particles are affected by the magnetic field and undergo switchbacks. What this means is that particles from the solar wind are travelling at different speeds, forcing the faster particles to overtake the smaller particles. This generates kinks in the magnetic field, where the faster particles are travelling ahead of the slower particles, which are lagging behind. The magnetic field lines even flip 180 degrees in some cases, which means that the solar wind does not have enough energy to escape the star's corona. The origin of these switchbacks in the magnetic field is thought to be caused by irregular patterns in the solar wind. Some of the plasma emitted from the Sun is fired in clumps out into space, escaping the Sun's gravity, while others fall back into the Sun's surface depending on the direction they were emitted. Because these particles are emitted in different directions, they are travelling at different speeds, disrupting the continuous stream of particles and forming the switchback in the magnetic field lines. Before Parker, solar storms and solar flares that reach Earth were thought to be rare occurrences. However, the final discovery that the solar probe made is that these flares are quite frequent. Parker saw many smaller emissions of high energy particles, which are accelerated from the surface of the Sun and spread out over a large area. By the time they reach Earth, they are almost undetectable, but not for the Parker Solar Probe. If it had not been right next to the star, then these small flares would never have been discovered. So in conclusion, there is already a large amount of scientific knowledge that has been discovered by the Parker Solar Probe in only its first year out of 7. The solar wind is much more intricate than we could have ever realized from here on Earth, and I can't wait to see what it finds next. If you enjoyed this video, remember to subscribe to the channel for weekly astronomy content. Show your support by leaving a like and starting the discussion down in the comments section about these new discoveries. Until next time, goodbye.